Hi everyone, in this video we're going to be talking about uniform circular motion. Now this section does not have to do with forces at all. It's just how objects are moving in terms of its velocity, distance, and time as it moves in that circular path. Here's a circular path, and a couple things to note is that the velocity is always tangent to the path of the circle. So if the ball was at this location here, right, the path would end up being tangent to that circle in this direction right there, right? And everywhere, if the ball is here, it's always tangent. The centripetal acceleration is always at a right angle to the velocity. So if the ball is here again, the centripetal acceleration would, of course, centripetal means pointing to the center. At every location that that ball is moving around its path, the acceleration always towards the center. All right, and of course the radial distance is from the center point of the path. We need a few mathematical relationships. So the first one for circular motion is that the velocity is constant. Correction there, speed is constant. The velocity is constantly changing since we have an acceleration, okay? And it's just the direction of the velocity that's changing. So if it's a constant speed, we have a constant velocity equation. But we're going to look at some specific aspects of the distance and the time that it takes to go around that circle. The distance for an entire circular path would be the outer edge, okay, from the starting position all the way around to back to where it starts, and that would be the circumference. And we find the circumference using 2 pi r. Now there's a special name for the time that it takes to go around once, and the symbol is a capital T, and that capital T stands for period. To solve for the period, what you want to do is take the total amount of time divided by total number of revolutions. And you're going to get units of seconds here. The standard unit for period is seconds. So it is a measurement of time. It's just the time it takes to go around once. Another property that is very closely related to period is the frequency. Frequency is the number of rotations per time. And it is going to be the symbol of script F. So that's the variable. And then the unit is going to be a 1 over a second, or a per second, which is the same thing as a hertz. And that's spelled hertz, H-E-R-T-Z. So frequency is really the opposite of the period. We already wrote down that the period is the time over the revolutions. Well, frequency is just the revolutions over the time. So that frequency is just the opposite of the period. If you always think of the definitions of frequency as in period as this mathematical type of relationship, you'll never get the answer wrong, all right, whenever they give you a problem. Frequency, rotations per second, all right, period, seconds per rotation. They're just opposite each other. The only other mathematical relationships we need are for acceleration. So the centripetal acceleration is equal to v squared over r. I don't know of any mathematical proof where that came from. I would imagine it came from experimentation, all right, and analyzing of data. Now what we can do is take the velocity equation for circular motion, which is 2 pi r over the period, and if we substitute this in for that v, we can put the acceleration in terms of the period instead of the velocity. So if we plug in 2 pi r over the period into where that velocity is going to be, so that needs to be squared, and put it over the r. If we square everything in the parentheses, so we get 4 pi squared r squared over t squared divided by r, right? What happens is this r cancels out with one of those r's, and we get our final relationship here of 4 pi squared r over t squared. And those are the two relationships for centripetal acceleration. So here are all the equations for uniform circular motion. Really what you're going to be tested on is using the period or the frequency information that they give you appropriately. One other thing you could do is substitute in the frequency for the period, 1 over the frequency for the period, and that will change up the equations a little bit, and they will look like this. They're basically the same thing, it just depends on how they give you your information. If they give you the frequency instead of the period, it's good practice to make sure you can change the frequency in the period, but you can always just plug them into those equations right there. So hopefully it's a nice, easy section for all of us.